Hello, welcome back to proximity math here. I'm gonna do the 2005 AIM 1, number 15. Let's go, baby. Okay, so triangle ABC has BC equals 20. The incircle of the triangle evenly trisects the median. That's the important part. Okay, the median AD, so the mid, it's the connection from A to the midpoint of the opposite side. Okay, yeah, that's for median. And since BC equals 20, this splits it into two triangles of length 10. Sorry, two length like line segments of length 10. Okay. If it trisects the median, then these three lengths are equal. That's all it means. The area of the triangle, so we have to find it basically, that's all. Okay. Now, well, if we let the length of this median be d, if we let AD be d, then we can first use Stewart's theorem. Okay, we can use Stewart's theorem on D, and if we let these opposite sides be C and B like that, then Stewart's theorem, we have um, or if we substitute Aime I, okay, M is 10, A is 20, N is 10, so we got by Stewart's theorem, okay, D squared times A is equal to B squared M times C squared N, which is just 10 B squared plus C squared. Okay, so now if you divide by 10 and take away the 1000, we get, so if you divide by 10, both sides by 10, and subtract 200 from both sides, then you get 2D squared equals B squared plus C squared, sorry, C squared minus 200. All right, and now what else can we use? We have no information on these sides at all, but we have a circle and intersections. And since it's an incircle, that's the most special part. We actually have these sides being tangent to it, right? So if we break the sides up using a very special substitution, it's a super clever one, you should learn it. It's also used for deriving most of the theorems with incircles. If we split each side using the equal tangents theorem like this, and these are the points where I'm splitting it at. So both these segments are of length x, and these are of length y. Oh, sorry. Wait, y is over here. Okay, there. And then all of this is going to be z. Okay, so we split them so that we have x plus y equals ab, y plus z equals 20, and x plus z equals ac, for example. Okay, first of all, we can use y plus z equal 20. As our first formula. Okay, next we can substitute actually we can use power of a point now. So if we use the tangent power of a point, it's extended power of a point, then we'll get that x squared is equal to relative to point A. So x squared is equal to this times this length. which is d over 3 times 2/3 of d. So using power of a point, we get this length times this length equals this length squared. Okay, so from that, we get 2d squared, multiplying both sides by 9. 2d squared is 9x squared. The reason I left both these as 2d squared is now they have the same coefficient, so we can easily equate these. Okay, so 9x squared equals, both of them are equal to 2d squared. So this is equal to b squared plus c squared minus 200. See? Alright, so now we can express b and c in terms of the three other variables we made, x, y, and z. So b, what is b? Well, b is simply the side opposite in point b, so it's x plus c squared. No. And then we had c squared. C squared in this case is opposite c, which is x plus y. And I made these substitutions with the three new variables to use power of point. Okay, now minus 200, of course. And this is equal to 2x squared. X squared plus, if you group the terms together, you'll get y plus c, and of course y squared plus c squared. All I'm doing is expanding these first two terms on the right hand side. Minus 200. Okay, that's a lot. Now it's just simple algebra ever since we substituted them. Okay, so now we have 7x squared equals 2x times, now if you remember, this is the only equation we had with y and z. Y and z equals y plus z equals 20, so this makes it 2x times 20 is 40x. Plus y squared plus z squared. Minus 200. Okay, seems like we don't really have enough information to go off again. So can we use power of point the same v again? Okay, let's see. The only 2 points we can actually use it on are A and D apparently, because we have the sections of D connected to those. Okay, so we can use D, power of point respect to D. So we have 1/3 of D times 2/3 of D equals this length squared, the tangent. And since this is y and the total length here is 10, this tangent has length 10 minus y. Okay, so we would get and multiplying both sides by 9, we get 9 times random symbols. Okay, so we have another value for 2d squared and 9 times 10 minus y squared. minus y squared. Okay, so, well, if you look at one of our original equations, look, see, it's both these are really simple. We have 2d squared is 9x squared, which is also 9 times 10 minus y squared. But since we have squares, we have to be really careful to take the correct root. And that's why it helps to draw a very accurate diagram. And you can easily notice y is far less than 10. So 10 minus y is the positive root. And it's equal to 10 minus y equals x. Okay, so x plus y equals 10. Okay. And now it's much easier to solve for this. So if x plus y is 10, wait, what do we get? We can actually use these equations again. I mean this equation again, and easily find out that if you compare the equations, you would get, I can't even draw 0. C equals x plus 10. And that's our final step to find it. Okay, now we can plug this in. That's our final step to finding the values in terms of x. See, we have both z and y. Okay, z is x plus 10. Y is x, 10 minus x. So z is 10 plus x and y is 10 minus x. And using those, actually, wait. No, never mind. Okay, never mind. 10. Yeah, if we instead take it back a couple steps and we substitute, we get 10 squared here and 2x plus 10 here. Gosh. Here. Okay. So, and this 10 squared cancels out with this 200 to make negative 100. Okay. Make sure you keep the algebra neat so that you don't make any errors. Sorry, my mouse is for some reason it's making rapidly weird movements. Okay, there. So expanding. Okay, expanding. No, we get 5x squared minus 5x squared minus well okay, you have 2 times 40x, and then this expands to 100 minus 100. So luckily we don't have to factor a big quadratic. Divide both sides by 5, and we get x squared minus 8x equals 0. So the roots are x equals 0 and 8. Obviously x is 8, and then since x plus y equals 10, y equals 10, and since z is x plus 10, z equals 18. And obviously we can find the area of the triangle from here. Okay. Now we're finally done finding all the values. X, y, and t. Okay. We can use Heron's formula. That's apparently our only way possible. Since we don't know the end radius, you can't use that in circle formula. What is happening here? So, our semi-perimeter, since these, if we add all the sides, we would get 2 each of x, y, and z. Because we have one side is x plus y, one is y plus x, z, and one is x plus z. So our semi-perimeter is just the sum of x, y, and z. It's super easy to see. Okay, the sum of these 18 plus 18, 36 times, and we have the semi-perimeter minus a, which is x plus y. Actually, if we have like some side a, for example, we have the sum, all this is the sum minus 2 of these. And this is exactly why sorry, this is exactly why Heron's formula is actually a lot simpler in terms of x, y, and z. So each of these terms, s minus aside, is one of x, y, or z. If you can work it out for yourself using Heron's formula. So we would get x, x, y, z. Okay, and now that gives our final answer. Oh, okay, x, y, and z, we can multiply it out. First, we have to multiply them. Okay. We get 9 times 2. We get 2 times 10. Okay, 4 times 5. Wait. Oh, y equals 2 actually. Okay, so y, don't make a mistake like that, sorry. X plus y is 10, so y is 2. And the rest goes nicely. Anyway, we have y is 2. So we get a 16 out of here. Okay. If you take out the 36, you get a 6. These multiply to 16, you get a 4. Our semi-perimeter has changed now. It's 28. All right. Okay. So anyway, if you take that 8 and 2 out, you get a 4. This becomes 2 times 9. So if you take the 9 out, you get a 3. And if you get root 56, take the 4 out, you get a 2. This is a 12 now. So 2 times 12, 24. And this reduces, if you divide by 4, you get 14. We're taking the the 4 out. Okay, this obviously cannot be simplified anymore since 14 is 2 times 7. Okay. Now, since we finally have our value, in the contest, it's asking for the final answer to be, if the area of the triangle is 24 root 14, basically find m plus n. It also tells us to take out any squares from the radical. Okay. So the final answer is the sum of these, which is 38. And we just did a simple Aime 15. It required a little bit of insight, but that made it really easily boil down. I really hope this helped you, and thanks for watching.